They give us these 3 points. So they say that Q point is 0, 3, and R point is 4, 4, and P point is 3, 0. And let's see, we are asked for 3 different angles. I'll do it for the first one. So LRPQ. So these are the 3 points on the triangle, and we're asked to find the angle LRPQ. So usually you draw it out first. So here's my XY axis, and let's see here. One of the points would be here. This is 0, 3, and this one they're calling Q. And one of the points would be down here, and actually let's draw it a little closer, maybe here. And this would be 3, 0, and that's point P. And then up here would be 4, 4, and that's point R. So I have this triangle that connects those 3 points, making my triangle. And for L R or angle RPQ, so this is RPQ, we're talking about that angle that is formed right there. So I'm going to label that thing. Let's call it theta. And by the way, don't forget, once you find 2 of these, once you find theta and let's say this other angle beta, then just do 180 to find the third one. 180 minus theta minus beta tells you the other one. So you only have to do this twice, and the third time just use the fact that when you add all 3 angles together, you get 180. Okay, so let's look how to do this. To find this, I have a vector that goes like this, and a vector that goes like that. And I'm going to call this V1 and V2. And in order to find the vector between 2 points, let's do V1. So to find the vector, for shorthand, I do the tip minus the tail for both of these. So tip minus the tail. And for V1, the tip minus the tail would be let's see, 0 is the x component of the tip minus the tail, which is 3, which is the tail component of the x component of the tail, and then 3 minus 0, that would give me V1. And for V2, I will have the tip is 4 in the x component minus 3 in the x component, and the tip for the y component is 4 minus 0, and that will tell me the vectors. So V1 is equal to negative 3, 3, and V2 is equal to 1, 4. And now I have a vector that describes the scenario that's happening up here. This is V1 and this is V2. Now we know that the dot product from V1 and V2 is equal to the length of V1 times the length of V2, or magnitude. Length or magnitude means the same in this scenario, times the cosine of the angle between them, which we're calling theta. So we divide both sides by the length. Solving for cosine, we get V1 times V2, the dot product of those, divided by the length of V1 times the length of V2, and that's equal to the cosine of theta. So in this case, we can use the arc cosine property, and after we find this number, use the arc cosine property, and we will have theta. So what is the dot product between those two vectors? Well, the dot product of V1 dotted with, so that's equal to minus 3 comma 3 dotted with 1 comma 4. So that's minus 3 times 1 plus 3 times 4, or minus 3 plus 12, which equals how much? 9. Okay, so that's the dot product. And then the length of V1 is negative 3 squared plus 3 squared. Then take the square root of that. So that's 9 plus 9 is 18, so that's root 18. And the length of V2 is the square root of 1 squared plus 4 squared. So that is square root of 17. Alright, so now we just put all those things together. So the dot product of V1 and V2 is 9 divided by the length of V1 times the length of V2. And I'm going to take away that to not make it confusing and put parentheses. And that's equal to 9 over 18 times 17 is 306, I think. Take the square root of 306. And that's equal to the cosine of theta. And so then 9 over root 306, take the arc cosine, that's equal to theta. And when I type that in my calculator, I got approximately 59 degrees.